All right. Um, you told me there wasn't another bell. We are going to continue with limits. We're going to do the new part of them today, but I'm actually going to be very naughty. And did you hear that, Mr. Scher? Or not naughty in a bad way, mathematically naughty, because I'm going to teach you how to do it without the calculus. I'm going to show you the calculus at work, but I'm going to say we're going to revert and do it a different way. You'll be far more accurate and you'll do them faster. I think perhaps a college professor of calculus would roll over in their grave if they heard it taught this way, but it's fast, it's accurate, and the first couple years I taught this, I didn't do it this way, and they weren't accurate. So we are going to, I'll show you the calc way, and then I'm going to say I want you to use pre-calc with a twist. All right, you just got to make sure you take the twist as it comes or your signs are going to be off. Fair enough? So because we're going to do it the fast, accurate way, everyone will finish their worksheet today. They all did last hour. So our goal today is we're going to change our approach. We're going to be finding limits as we approach the infinities instead of approaching constants. So in your notes, let's go to, I think I have them back here. Back here. Back here. All right, so go to this page, and we're going to talk about pre-calc with a twist. All right, so on those two graphs, we're going to draw two functions, and we're going to first see graphically what it means to take a limit as you approach the infinities. My first function of choice is just going to be kind of like this. I just go ahead and draw with me like this. I'm going to go like that, but I'm going to go like this as I head to infinity. So I'm heading over here towards infinity, and I'm looking at what's happening with that function. All right? It appears like it's being bound. It appears like it has a y bound. Wouldn't you agree? And that's what limits are. They're y limits. They limit the y value of a function. This function appears like it's being bound up here at, let's say, 1, 2, 3, 4. So what I would say based on this graph is that my limit, as I'm heading towards positive infinity, of that function, y equals f of x, or of the y values, appears to be 4 in pre-calculus. This was also discussed, but it wasn't discussed as a limit. Do you remember what the topic of discussion was? And you said, oh, the answer is y equals 4 for the, go ahead and say it, horizontal asymptote. Yeah, so our limits at infinity can be thought of as horizontal asymptotes graphically. We're going to have to be careful how we answer some questions, though, because if my next function looks like this, and it appears to be, when I'm looking at it, I can't put a y bound on it. I can't put a horizontal asymptote on it. So last year in pre-calculus, you would say there isn't one, or they don't exist, or whatever your calculus teacher told you to put, right? But we have to refine that because there is no horizontal asymptote, but there is a limit. As I head to infinity, what's my limit of that function up there? Infinity. Right? So we can't write there isn't one like we did in pre-calc, but it's similar, right? There isn't a horizontal asymptote because the function's unbound. I think perhaps in calculus they actually, pre-calc, they discuss this as well, but they have horizontal asymptote discussion and an end behavior discussion. Does that sound similar? That's really what we're doing today with a little bit of a twist. So I'm gonna stick with that because it's something you already know. So it appears that these limits at infinity are providing you with these horizontal asymptotes. Graphically, that's what they're providing you, so that's how we are going to find them. All right, so there's one key thing to this, and when you have a rational function, which really just means some polynomial over some other polynomial, I'm going to call it p of x over r of x. I'll put a fake one up here, but I'm going to make my top polynomial a constant so you can see it. On the bottom, maybe I'll make it x to the 99th minus 3x squared. Just two very strange looking polynomials. For any rational function, you do need for the calculus of this to know a very important fact, that no matter what constant, that's what the C stands for, meaning this could be a 5, a 55, a 555, or 9,999, or -2. When you have any constant on the top, and you divide by x to any power, again, that power can be 99, 4, 1, all right? When you divide any constant where r is positive, so you have a positive on the bottom, this will always go to 0. There is a proof of that we can't do right now, but that fact you need to know, that when I take a limit and I head to either infinity, it could be plus or minus, and I put any number on the top and any positive power on the bottom, regardless of the power or the number, what's that going to go to? 0. This should sort of make sense to you, right? Because infinity is a destination. So even if I put all these 9s on here, when I approach infinity, x is actually that with a gazillion more 9s. So it still will go to 0. Does that concept make sense to you? All right, so let's go take a look at this basic example using that. This is similar to one on your test on this chapter, and the test is multiple choice for the most part, which I rarely do, but there's not a whole lot of work you need to show, so there's not a whole lot of work I need to correct. So I think half of it's multiple choice. Some people would just do this in their head. I'm going to show you the work though. No matter what happens, when my function of question is a constant, it doesn't matter what my approach is. If y equals 5 is my function, that's a horizontal line, agreed? And no matter where I come in from, maybe I'm approaching 2 from both sides, I'm still up at 5, right? Maybe I'm approaching negative 99 from the left, I'm still up at 5. And if I approach the infinities, guess where I am? Still at 5. So no matter what, this first part of the limit would be a 5. And then you're subtracting what happens. Limits can be split into sums, differences, products, quotients, all that good stuff. You're doing that. And what did I tell you this goes to? 0, right? This will tend to 0 as x tends towards negative infinity. I'd just be left with the answer of 5. That's just a very basic kind of limit discussion. So let's go to the next page. I want you to take a look at this first one. If this was phrased in pre-calc, it would have been phrased as find the horizontal asymptotes of the function, and they would have written it y equals 2x minus 1 over x plus 1. What would your answer have been? 2, because you were taught to do what? You look at the coefficients. As long as the powers are tied, they should have said, you know what? Go to the highest power. If they're tied, you steal the coefficients. Really, there's more math to it, and I will show you that. But was I accurate getting that 2? Was I super fast getting the 2? So the calculus just makes it slower. But I want you to know why you're able to steal the coefficients. So I am going to show you the calculus one time on each type. Fair enough? So I don't want to shortchange you. I want to show you why you are allowed to say this is 2. All right? Basically, the top's going to infinity, and the bottom's going to infinity. They're both tending towards infinity. That's what's called an indeterminate form, just like 0 over 0. So indeterminate form, just like 0 over 0. If you were to ask somebody on the street what's infinity divided by infinity, guess what they'd probably say? 1. Yeah, it's not, right? Infinity is not a number, it's a destination. So it kind of just depends on how far you get toward infinity on the top versus how far you get towards infinity on the bottom. And when I took my limit, this actually was a 2. So think about it that way. We have another indeterminate form. There's actually 7 of them in math, but only 2 in Calc 1. The other 5 come in Calc 2. We had to deal with all of them, all right? So without calculus, let's just talk about this one because I really would do this without calculus because I understand it's a horizontal asymptote, and my pre-calc teacher told me that if I go to the highest powers and the coefficients are they're tied, I just take the coefficients. So if that's memorized, you're accurate and you're fast. So what is this guy's limit right here for my function? Right? My limit as x approaches infinity is what? Of the function? Yeah, you're right, 2/3 or 4/6. How about as I approach negative infinity? You didn't have, what do you think it is? It is still 2/3, but think about why it's still 2/3, and that'll give us some help with signs. In the grand scheme of large numbers, those lesser exponents aren't contributing much to the power of the function, right? So if I approach negative infinity, and when I think of negative infinity, the number that pops into my head is negative 99. I mean, you can have whatever. But I picture raising it to the 5th power. What do I get? Negative, negative. So with sign analysis, I'm going to have the same limit from both sides. That doesn't always happen. Some end up being positive, some negative. You just don't know, right? You have to do a sign analysis. And on my graph, that looks about 2/3-ish. So it all looks great. How would the calculus give me the same answer? So let's go to the next one. We're going to go look at letter A first. You okay with that? Letter A. If this was pre-calc, let's see if you're fast and accurate with it. And they asked you what the horizontal asymptote was. What would you say? Y equals 0. So that's another difference. It's y equals because it's a line. Our limit's going to be a number, but what do you think our numerical answer is? 0. Were we fast? Yes. Were we accurate? Yes. So I would like you to do this one that way and say, yep, it's 0. That's the limit. Right? Y equals 0 is what I'd put if they asked me for the horizontal asymptote. But why? And you might say, because it's got more power on the bottom, and when you divide little things by big things, they tend to go towards 0. That's a great thought, but that's not a mathematical why. So I am going to show you one time the calculus of it. If you were taking, a college professor would hate me today, I already told you that, because they would want you to do all of them this way, because this way is mathematically sound. Just saying, I can just steal the coefficients. Well, why, right? So let me show you what they would tell you to do for this one. They would say you divide the top and the bottom by the highest, I don't know how to word this really well, but I'm going to say highest power of x, but really what I mean is x to the highest power you see. So that would be worded better in a college text, but I can't figure out the best way to word it. So they wouldn't call it x to the HP, but we're going to find the highest power. All right, so I'm going to go up here, and if I were taking this at the U of M and we were talking about limits at infinity, they'd say, you know what, you got to go to x cubed because it's in control. Right? And what we're going to do is divide everything through by x cubed. The y that you can do that I'm going to put in red. Don't put it in your notes. Dividing is really the same as multiplying by 1 over x cubed. On the top and on the bottom, I will multiply everything really by 1 over x cubed. And really, what am I multiplying by then? If I'm doing the top by it and the bottom by it, I'm multiplying by 1. So I don't change the integrity. I just give it a facelift. So really, that would be presented in a collegiate text as multiply the top and the bottom by 1 over x cubed. Make sense? But really what happens is you end up dividing everything by x to the 3rd power. I'm going to show you it. You can write this one down. The other two I'm going to have you just watch because I'm going to cruise through them. But really, you would be told. I had one kid years ago who chose to do them all this way. He was very accurate, but what was he? Very slow. So that's what you give up by doing it the way you should be taught to do it. All right, which is what I'm going to do right here. I'm going to take this and divide it by x cubed. I'm going to take this one and divide it by x cubed. I'm going to take this one and divide it by x cubed. And I'm going to take this one and divide it by x cubed. Really, I've multiplied the top and the bottom by 1 over x cubed. And I'll give it a new function that's got the same integrity. Okay, my new function, I don't want to rewrite. On my new function, these would cancel, so I'd really have a 3 there, right? It's the same function as the original. I just got rid of, I just did something very legal. This one would have an x squared on the bottom. The rest are as good as they get. Now watch what happens. As x goes to infinity, what will this part go to that I'm circling here? What's that going to go to? The people listening can't see what I'm pointing at, so that's why I circled it. But what's that going to go to? 3 over gigantic. What's it going to go to? 0. Even if this was 3 billion over x cubed, what would it go to? 0. So all these, this is going to tend towards 0. 2 over x squared is going to go to 0. 1 over x cubed, any constant over x to any positive power will go to 0. So what I'm left with on the top is 0 and the bottom is 3. What is 0 divided by 3? 0. That's why, the mathematical reason why we say. But when you see a higher power and you're approaching infinity and it's in the denominator, what's your answer going to be? 0, fast and accurate. I'm just showing you the why because I feel like I ought to. Let's do one more. We won't do part C. You know the answer right now, you should. What is its limit? Negative, 2/3. Make sure you bring the sign of the coefficient with it. I know my answer is negative 2/3. I was fast, I was accurate. Agreed? Here's the y that you can just watch. I would divide everything through by what? X. X to the first, X to the highest power. I'm not going to use good notation either because I really want to show you this, but then I'm going to tell you not to use it anyway. This is totally legal. I just multiplied the top and the bottom by 1 over x, and I'm going to get a new function with the same integrity as the old one. I'll clean these up. Just watch so you can see why your pre-calculus, why did I say it like that? Teacher said just steal those coefficients, guys, and you'll be accurate. And that's totally how I would teach it too. What's this going to go to as x goes to infinity? 0. What's this one going to go to as x goes to infinity? 0. I end up with 0 minus 2 on the top over 3 minus 0 on the bottom. That's why you get to steal the coefficients. Are you okay with that? I will not make you do it this long way. And there's really not a whole lot of benefit to it either. All right, so let's flip the page. So this is what you would have been told for how to find horizontal asymptotes. There are code language actually for limits as we go to infinity. And using the rules about the powers, you'll be very accurate. You're just going to have to really be careful with some of them. All right, are you ready? Number 9. What's my answer? Fast and accurate. 0, done. Go ahead and put it down. It's done. That's how I want you to do it. There's no point in not doing it that way. Wouldn't you agree? It's not very mathematically sound, but I'm fast and I'm accurate. Let's go to that. Just 1 second. Go to number 10. Locate those highest powers. Everything else should leave your brain. I even sometimes tell kids cross off everything but the highest power on the top and the highest power on the bottom. Agreed? What's my answer? Fast and accurate. 4/5. Did you have a question? No. I'll show you. I have AP samples next. I've never seen one, and I've looked at every year back to at least 2002. So nope, it'd be worth 1 point. They sometimes ask you what's the limit as x goes to infinity, but it's just a what is it? And you put a 2 down and you're done. So I think there was one. Wasn't there one in your last packet, I think? I want to say there was, and you didn't have to even use. No, it's if it's asked, it'll be very much like it'll be like a part D, and it'll say what's the limit as x approaches infinity. It'll be worth 1 point, and on number 10 you'd put 4/5, and you'd get that point. All right, good question though. Number 11. Okay, I see who's controlling the top. I see who's controlling the bottom. Now, last year you would have said there's no horizontal asymptotes. My limit is now one of 2 things. Because now limits are the y behavior, right? End behavior. So my question is, how do you think you decide whether you put an infinity or a negative infinity? Sign analysis, exactly. You just say, well, I'm putting in positives, guys. And in my head, 99 pops in. When I think of infinity, my brain puts in a 99. That also is super illegal. Because infinity is not a number, it's a destination. But I kind of stop my way there when I get to 99, and I say, so I'm going to throw in a 99. It's helpful, and it's accurate. On the top, when I throw in a 99, will be positive. The bottom, when I throw in 1, will be positive. So where's this one going? Infinity. I'm done. All right. Now look at number 12, and let's see about how we can think of that. We have several ways. Who wants to give me a way to think about number 12? Because that's weird. Anyone want to get me rolling on number 12? What do you think? Go ahead. Sure. Why not? Because I don't like it. I don't have to, but I certainly would think that that's a pretty decent approach. So she said multiply by the reciprocal, and I'll get 4x minus 5x cubed plus 3x. Same integrity, different appearance. And what did I do? 4x squared, thank you. Now I decide who's controlling this polynomial, this guy with his coefficient. Make sure you bring the whole coefficient. The other ones leave my brain. Not very legal, but very fast, very accurate. Like a college professor would never say, cross them off, have them leave your brain. Like this lesson would really bother them. All right, but it's fast, it's accurate, and I like it. All right, so do you think this one is going to go to positive infinity or negative infinity? As I approach infinity, I'm thinking positive numbers. This guy's in control. There's a negative in front of it. It's going, end behavior is, it'd be heading down. All right. I said there's another way to think of it. If you wanted to think about it as who's in control, you would think of that as x to the negative first, correct? In which case the top is still got a higher power, so I'm still heading to one of the infinities, and then I do sign analysis. So either way is good. Now I need to slow my roll a little bit, because this could have been taught in pre-calc. If I just changed the word horizontal asymptote to limit at infinity, I could have been teaching pre-calc for the last 8 minutes, right? But you wouldn't have had one like number 13. What's different about it? The root. All right, so there's the way I should teach you how to do it. There's the next way, which I kind of should teach you how to do it, and then that's the way I'm going to teach you how to do it. And you're going to be fast. I'm sorry, I've taught it all ways, and I'm like, I just got to, I'm going to teach with common sense. I almost think that common sense trumps everything else anyway in the real world. Wouldn't you agree? So here's what I'm going to tell you. What's the square root of x squared? It actually isn't. So that's we're going to think of it as being x. It's not x. What's the square root of negative 5 squared? It's the square root of 25. And what's the square root of 25? 5. If you've been taught the square root of x squared is x, it got you through, but it's really not what it is. Do you want to tell me what it actually is? It's the absolute value of x. Yep, square root of x squared is the absolute value of x. I'm not going to have you think about it like that, though, but it is what that really is what it is. I'm still going to have you go like this. Get rid of all non-highest powers. Just crossing them off right there kind of hurts the mathematician in me, but really just get them out of your brain. Don't look at them. You'll be really accurate. All right, the next thing I want you to do is, like we've been doing, locate the highest powers and look at them. The top actually is not heavier, because when I see the square root of x squared, what am I thinking? X. It's actually absolute value of x, but my head's thinking x. Agreed? So they are actually tied. My two possible answers, because they're tied and I'm thinking x, I'm thinking the answer's a half. Agreed? I actually have to decide the sign of it again. So to be accurate and quick, I head to infinity and my head thinks of 99, right? And I picture squaring it and taking a root, and that's positive. I picture multiplying it by 2, and that's positive, so my answer is a half. Are you okay with that? We'll go do one later where that sign analysis actually, you might have said, I know it's a half, but there's some where you're going to actually have to dig in deeper. Let's go look at this one. What did I do? It's almost the same problem, but what did I do? I'm heading towards negative infinity. It doesn't mean you're always going to get negative a half, because, by the way, you have a worksheet where you have to do both. And a few people last hour were saying, well, if it went to 4/9, then the one going to negative infinity will go to negative 4/9. That's not true. You actually have to test them. Here's what you do, though. You still go like this. You're gone. You're gone. Agreed? I'm still thinking the top is x. I still am thinking they're tied. I'm still thinking my answer is some sort of 1/2, and then I do sign analysis. I pick my favorite number. Who do you think I think of in my head? Negative 99, right? I square it. Technically, I can't square infinity. It's not a number, right? But in my head, I go to negative 99, I stop, and I square it, and I get a positive, and I root it, and what do I get? A positive. So I'm thinking the top is going to be positive. On the bottom, I think of negative 99. And what is it? Negative when I multiply it by 2, right? So that's negative a half. Now, let's go play. Are you ready? Go do, here's some multiple choice as it appears on the AP exam. FRQ is hard to find. And usually just a lone little point, like I just told you, like 1 point for putting an answer down. Go do number 1. Rephrase the limit as a horizontal asymptote, so they all say y equals. But this is a past AP test, and you shouldn't need any work. You should be very fast and very accurate. Which one, you can go ahead and blurt, which one would have a limit of 5 or a horizontal asymptote at y equals 5? Go ahead and blurt. And you can't hear if you're listening to this, they're saying E. And that's totally true. I can see it because I'm looking at if I see these tied, I'd go to E. By the way, though, let's talk about the other ones. What's this guy's horizontal asymptote right here? Negative 5. What's this guy's horizontal asymptote? 0. The bottom's taking over. What's this guy's horizontal asymptote? There isn't one. It's a line, correct? What's this guy's? I don't care. It's not that. It's not 5. So next one up. This is I do this every year. The same thing happens every year. It happens second hour. So I'm going to have you guys just take a peek. And then I'm going to have you blurt the answer loudly, please. I'm being an evil genius right now. Are you ready? You should do it that quickly. Number 2, blurt really loud. Blurt. Go ahead, blurt out. Not A. Blurt. What do you, E, not E. No, nope. None of, if you're listening to these 5th hour, all my science trip people, nobody's blurting the right answer. In my second hour, I heard a predominant E, which is usually what I hear. So it's kind of weird that you guys are saying A, but the reason I threw this one on here is if I had had you blurted out 2 days ago, you would have done it correctly. So you got to make sure that what we're doing today doesn't mess up your knowledge about approaching constants. I'm not approaching infinity. Right? So be careful. Don't now all take every single limit you get. Now on your worksheet, they're all infinities, but this is approaching 0. You got to follow procedure. What do we do when we approach a constant? We plug it in. If we get a numerical answer that's not an indeterminate form, we're done. But I plug it in and I got what? 0 over 0. That doesn't mean my answer is 0. You guys know that. You know procedure. You plug it in, you get 0 over 0. What must you do? Go ahead and say the word. You factor. Exactly. You have to get rid of the issue. 0 over 0 is being caused by there being x's in here that must cancel. So I have 2x cubed. You guys know the procedure, but every year kids bail on procedure because they just go, oh, higher degree on the top, boom, E, right? The top needs to get factored. The bottom needs to get factored. Make sure I'm factoring correctly. X squared, what, plus 3? You guys know that. I dropped my limit, which is illegal, but I would back that and argue that it's multiple choice, so nobody would know. So that's why I didn't write it, but there it is now. Once you factor, follow procedure. What do? Cancel. Yep. Once you've canceled off that issue, the thing causing the 0 over 0, follow procedure. What do? Yep, replug it in. Awesome. When I replug it in, I don't get A, I don't get E, and I don't get B. I don't get any of the things you said. I get a 6 on the top and a 3 on the bottom. Nobody said D. So do you see why I threw that one on there? I'm going to caution you 2 things. Always when you're doing a limit, look at what you're approaching before you launch into process. If you're approaching the infinities, then follow that process. It's completely different than when I'm approaching a constant. If I changed this to an infinity, the answers would look a lot different. They would have put an infinity here, a negative infinity, probably a 0, right? Probably let's keep those other 2. If I changed my approach to positive infinity, what would my answer now be? Now it's A. Do you see the difference? So be careful. Let's go and take a look at another AP question. All right, I can tell this is an asymptote and limit question because the graph gave me the asymptotes. So let's go take a look at what it says. Here's what that's the graph of, guys. It's missing some A that you should be able to figure out and a B that you should be able to figure out. Guess what's going to help us figure out what A and B are? Those asymptote placements. One of them super easy. Do you think it's super easy for me to get A or super easy for me to get B? A. Right? The reason I can get A is because A would be the horizontal asymptote because those coefficients are tied, right? I mean, the powers are tied. I'd steal the coefficients, so A has to be a 3 because there's a horizontal asymptote up at 3. Knowing that is nice because I can take out this, this, and this. Agreed? The vertical asymptote tells me something about what's got to be on the bottom. Where's the vertical asymptote located? At what? 2. That means in the denominator, what must there be? There has to be something. If 2 is giving me a vertical asymptote, what's got to be on the bottom? X minus 2. Okay? There has to be. So your choice is, do you want that to be x squared plus 4 for E or x squared minus 4 for D? Which one would give you a vertical asymptote at x minus 2? The minus, yeah, the difference of squares. The x squared plus 4 doesn't even factor. So B would have to be a minus 4, and the answer is this one. Now let's go a little easier. Let's talk about, those are the two trickier ones I could find. More typically, they look like number 4. To be honest, more typically on the AP exam, they look more like number 4. I gave you two atypical ones. I like to find the harder ones because I always tell you we practice harder than we play. Go ahead. Number 4, you should get it fast and accurate, right? What's the answer? B. Yep, I am watching my approach. It is infinity. I just look at the coefficients of the highest, but I'm done. Similarly, let's go do these two, all right? The one on the left, I can be super fast and incredibly accurate. And if I'm not, I haven't been paying attention. The one on the left, blurt it. 1/2 and I'm done. Because I'm approaching infinity, I just steal those coefficients and I reduce and I am done. That is the limit. If I asked for the horizontal asymptote, you'd say y equals 1/2. I need to slow my roll on the next one. Are you ready? And I'm going to give you a very illegal way to think about it mathematically that really is accurate. Here's what I'm going to tell you to do. Slow down. Cross off things that aren't in control. Watch out that you don't cross off that negative sign. Okay? Then I'm going to tell you to consider where the highest powers are. Highest power on top, on bottom, or tied? What do you think? Top, bottom, or tied? Visually, it looks like on top, but it's under a root, so it's really x. It's the absolute value of x, but whatever, right? They are tied. So my answer has to be the coefficients, which means I'm debating between root 3 over 2 versus negative root 3 over 2. You need to stop and be 100% sure, because if I'm giving you a short, accurate way to do it, you can't be guessing between those two. You actually have to figure it out, and this is how I told you to do that. It's a common sense way. I kind of head towards positive infinity, and what pops into my head? 99 does. And I put it into the top, and I say if I put in a 99, squared it, multiplied by 3, took a root, I'd be positive. I just go like that. If I put a 99 into the bottom, what would that be? Negative. So that tells me this one is my answer. So having said that, you can skip this guy because it's very similar. I want you to go try this one. Once you get it down to a 50-50 guess, you can't guess. And again, these are usually multiple choice. And I'll put down the answers that if I were writing the AP exam, I would put, because I always put things kids would do incorrectly. So we'll talk about that. You guys can contribute them for me, and then we're going to be done. You'll go finish your worksheet. You will finish in class. Everybody did. Are you ready? We're all working for College Board right now, and we're sitting around creating a test, and we put distractors that we know. We don't just throw random numbers. Everything that they choose is a what? Possible student error. All right? So when you make an error, you usually find your answer if it's a very common error. So here's my choices. All right? Why would they pick that one? The kid who visually sees a higher power where? In the denominator, that would happen. Once you see that, like kids would do that. When I head over to letter B, the kid who does see that as being x, even though it's not, it's absolute value of x, but whatever, and does this, is going to be debating between these three. And then I'd probably throw an infinity on because maybe somebody just doesn't get it, right? Next. You're debating between which two just because we get it and we're using common sense. Who are we debating? B and C. Yeah, you're out. You're out. How do I seal the deal? In my head pops a what? Negative 99. In my head, you can do whatever you want. You do you. When I put that negative 99 in right here, the top is positive. When I put the negative 99 down here and squared, it's now positive. And then I root it and it's still positive, right? So as I head to negative 99, which one's my answer? I mean negative infinity, sorry. What one's my answer? See, how many of you chose 3? Good. If you didn't, you probably chose negative 3, am I right? So we got to be careful with that. Take out your worksheet. We're going to I might as well keep this on because we're going to go answer a whole bunch, super fast and accurate, and then I'm going to have you flip the page and slow your roll. All right, are you ready? Yesterday's worksheet where it said end day 1, I think it's problem 20, whatever, doesn't matter, 8. All right, I'm just going to look at them upside down. We're going to cruise, we're going to be fast, we're going to be accurate, and then I'm going to pull the reins back a little bit. All right, let's go. 28, what's the limit of 6? And I don't even care. What's the answer? 6, it's a horizontal line. Okay, let's go to 29. Where do you think that's going as you approach infinity? Negative infinity, and if I think of it visually, it's a line going downhill, right? It's going to negative infinity. Number 30 is some sort of a polynomial, so I'm really kind of looking at end behavior from pre-calc, and I really am controlled by the highest power. What's the highest power? Look, I'm just making sure it's in order. Yep, so 3x to the 4th is in control. So do you think we're heading to infinity or negative infinity? It's going to be positive infinity because I'm thinking negative 99. I'm raising it to a 4th power, right? It's going positive, so we're good. All right, number 31, go ahead and blurt. The answer, quick, fast, accurate, what is it? 1/2. Move along to number 25. Quick, fast, accurate, what is it? Now I'm going to have you skip, and I'm going to say be careful. Go down to number, move your hand for a second, I'm sorry, 36, and tell me why I'm saying careful, careful. Last hour they blurted 4 ninths, and I said careful, careful, slow your roll, right? It's one of the infinities. How do you know that? That highest power is actually on top. It just wasn't in the right order, so be very careful. Now, before you write down infinity, you have to do a sign analysis. You have to take who's controlling the top, so you're going to look at negative 5x cubed, and who's controlling the bottom. Who's controlling the bottom? 9x squared. You have to look at both of them before you pick, right? So I'm picturing, is that a negative infinity that it's approaching? It's hard to see from up here. It's really tiny. All right, so in my head, I'm picturing putting in a negative 99. And on the top, I will cube it. It'll be negative. I'll multiply it by its coefficient, and that just turned it to what? Positive. See how accurate that is? It's super good. Super naughty. All right, on the bottom, I picture my negative 99 going in. I squared. It's now positive. 9 in front. It's still positive. What's my answer for sure? What is it? Positive infinity. All right, now flip the page. All right, we're going to go look at number 8. All right. Actually, we're going to look at 10 instead because there was kids who finished, some had 10 wrong. And here's what they were doing. They were assuming if the infinity approach gave them a 1/2, then negative infinity would give them a negative 1/2. That's not true. You actually have to analyze signs. So let's go answer it. For part A, it says I'm supposed to head to negative infinity, B is to positive infinity, and C is to write equations for horizontal asymptotes. Are we good? So let's go down to number 10. And let's do it LaRue's way. It's fast, it's accurate. All right? I cross off the weak players. So I'm crossing off everything on the top except negative 4x squared, and everything on the bottom except positives. Keep the coefficients with the signs. All right? Then I'm debating where the highest power is. Top, bottom, tied. Tied, not on the bottom, right? So slow down. Square root of x to the 4th would become an x squared of sorts, and so they're tied. All right, are you ready? So for part A, I'm supposed to head to negative infinity. My answer is either negative 4/7 or positive. Oh, it's under a root though, right? So negative 4 over root 7 or a positive 4 over root 7. How do I decide? I actually start my way on going towards negative infinity. And what number pops into my head? Negative 99. It's just, I think this is the best way to do it. On the top, I'll square it, multiply it by a negative 4, and my top is negative. Agreed? On the bottom, what will it be? Positive. So what's the answer for part A? Negative 4 over what? Square root 7, not 7, right? Now watch us do B with the same thing. Now I'm heading towards what in my head? 99, right? What sign will be on the top? Negative. What sign will be on the bottom? Positive. What's my answer again? Negative. Do you see how it didn't switch? You really truly have to analyze each one. And then my answer for part C, what's the horizontal asymptote? Y equals, there's only one of them, y equals negative 4 over root 7. All right, you go cruise, you'll finish the rest, even though there's 10 minutes. They finished last hour. Most of them did. I actually think all of them did.